All right, thank you guys for the honor of sharing some time with me. At this conference here, I admit check. Checkity check. Yep. Oh, it just got a battery light going. Yeah. Should I just speak up? I can do my best to just be loud.
Okay, yeah, shoot.
Okay,
all right, thanks.
No problem. So I feel like a welcome foreigner to a new world because I am a CAD user and developer who supports other CAD users. What I'll be sharing with you today is first a little bit of what my world looks like. So one of the things that I've been doing is helping people who only speak the language of CAD to utilize the world of GIS by essentially being a data translator. Here's a typical job that I've been working on. This is a large interchange in Milwaukee, Wisconsin, and I'm managing a team to help them collaborate in a three-dimensional space. So one of the roles that I play is to facilitate things like clash detection reviews. And so in the lower right, I'm showing what it looks like when we take a look at multiple different disciplines in that design project and systematically find out if there's any interferences so that we can resolve them before construction. Now, over the past 2 days here at this conference, I'm hearing something very similar to a lot of the other conferences that I've been invited to speak at. Usually it's in the transportation industry, and I get to share about my experience with automation and 3D modeling. And a theme that I'm hearing both at those technical conferences with transportation and here is that we're all experiencing a shift in culture and a shift in paradigm. And this is being brought on by not only the new technologies, but the volume of emerging technologies there are. This is enabling efficiencies and collaboration that, quite frankly, my industry doesn't know what to do with. This presents us with this gap between the realized value and potential value of the open data and the open software tools that are accessible to our industry. So question is, what does this gap look like, and what are some of the ways that you can go about to bridge this gap? In the remainder of my presentation, what I'm going to share with you are just a few examples. I consider these baby steps or very low-hanging fruit that I can start to glean from some of the value that's out there being shared openly and provide them for my project teams to be using them in platforms that are familiar with them. So the examples I'll share are a few examples of generating existing terrain models using open DEM data and open LiDAR data and tools, as well as an open source tool to create a data-driven visualization that enables a project team to explore other project users as well as resources on the project. So before I get into the open DEM data to generate a terrain model, I'll share a little bit about what the traditional workflow or approach is in transportation projects. So typically, the owner, or in this case a state DOT, is going to provide the terrain. They're going to provide it in the coordinate systems that the project is being worked on, and they're going to provide it in the software that the project team is utilizing. If we're talking about a surface during the planning phase of the project, the only thing that we've got access to are whatever projects were previously surveyed. That, of course, is going to present a lot of gaps or missing data to the project of interest. And if we're talking about a design surface, then we're going to be limited to the footprint of the project, which is going to be surveyed typically about 500 feet beyond the alignment. And quite often, there are extensive information, additional survey that needs to be captured in order to complete the project. Now, certainly for preliminary and design phase of a transportation project, it requires the higher level of survey, of accuracy and survey control in order to accomplish that project. However, for the planning phase and for visualization, this is where open source data and tools really brings a big bang for the buck. And that's some of the examples that I'm going to share with you today. So first, a way that I've used open DEM data to support a project in the planning phase. Here I've listed some of the sources. The top source listed is my go-to for finding and accessing, downloading DEM data. And so this data that I use, it comes in a form of a raster image. And the first task is essentially taking this raster data that's got elevation data embedded into it by virtue of its color and translate it into ASCII data that I could use to import into my project. Now, I'm pretty proud of myself because yesterday during the workshop, thanks to Randall Hale and a little bit of Googling, I found on GIS Stack Exchange instructions for how I could utilize the QGIS application that I just got my hands wet with yesterday at the workshop. And before I was showing a slide here of how I used a proprietary software to do this, but yesterday I did it in my hotel room and was actually able to replicate those results. So once I've got this ASCII data, now mind you, in the project that I'm working on, it's a much smaller area relative to the data chunks that get provided. So typically it's a 1 degree by 1 degree piece of data. And so the next thing I need to do is subdivide it into smaller regions. And I developed a CAD application in order to parse that out into manageable size. Next, I wrote another application in CAD to display just the segment that I was interested in, displaying the three-dimensional points. And then I had to reproject that information into the project-specific coordinate system. And I did that in the CAD application. So finally, I needed to import that into a digital terrain model so that I could provide that as a DTM for the project team to work on. And this is a look at then the final DTM that I was able to provide to the project team. Some of the feedback that I got from the engineer I provided this to was, number one, since they didn't have access to this initially, he was very impressed by the amount of time. It only took me a couple days to turn this out for him. And then second, he was very impressed by the level of resolution that I was able to provide, given this large data set. So next, a very similar process, but this time using open LiDAR data. So here are a few of the sources. Every time I go to search for places to access this data, I find more and more sources of LiDAR that are coming online. And the top one here, I used the USGS source, as well as one that was specific for this project, which is in Ohio. They had the OGRIP site. And so the first task that I did after downloading a bunch of LAS files was I needed to discern which of these are close to the project limits where my animation camera was going to be near to for higher resolution versus the ones that are going to be further away. And so I wrote a CAD application which took the metadata files that came in from the LAS data, along with the LAS data, and I generated a visual representation of where all those ranges were, labeled so that I could sort those and collect just the ones that needed to process accordingly. Now, this LAS data, it comes pre-classified with a few different classifications. So there's vegetation that you see in the blue, there's structures in the white, and then the ground, which I was interested in. And here's just the ground-only points that I used in order to generate the terrain model for this project. This is a visualization project. So the next step I did was to filter this data using an open source LASTools. Now, there's multiple different command line operations to use, and I used 2 of them for this. So the first one I used was the LASThin command, and this essentially filtered out so I could just get the bare earth data points that I was interested in, as well as get the resolution that I was interested in from the different far, mid, and near surfaces that I generated. And then second, I used the last-to-text command line, and that was in order to translate those LAS files into, again, an ASCII format so that I could digest that into my CAD applications. So here's a look at the triangulated surface, and you'll notice the much higher resolution that's near the project limits versus the coarser that's further away. Here's a look at the entire project. It's a 16-mile design-build project that's cutting through quite a mountainous range. And then this is what it looks like after I applied the image materials. And these are ortho images that, again, were open data from USGS that I acquired. So my final example here of open source is open source data-driven visualization tool. First, for those of you who are unfamiliar with it, d3.js is a JavaScript library that uses the underlying data that you feed it in order to present an interface with an interactive, potentially interactive visualization. And here are 3 common visualizations of data-driven. So a little bit about the data that I used to create an interactive visualization. All of you using your workhorse applications have menu bars, drop-downs, toolbars, and buttons that give you access to all the tools that you do your work with. On the projects that I support, above and beyond those, there are hundreds of other tools that I've either developed myself or compiled, and oftentimes I'd hear at some workshops trying to provide these tools to the project users, I'd hear the feedback of, Chris, I wish I would have known about that tool last month when I was doing the job. And so one of the things that I developed was a project toolbox, and it's a searchable interface that's been used for over 5 years, 150 project users, and over 400 project tools. So it's searchable. You can click on the tool and use it in the CAD application. That's what's collecting this data. So the first task then was to take the XML format of the data that this application was collecting, and it's collecting data from each user, when they searched, what they searched, and what they ended up using. So in Excel, I wrote a VBA to essentially translate that XML data into a few CSV files. One CSV file contained all of the nodes of users and tools, and another one of the links of their usage. And then there's a few examples here that I list. One is my code, and another of a selectable force-directed graph that is accessible from the d3.js or d3js.org online. And there's just a plethora of different examples that you could steal that code and hack away. And that's exactly what I did, is hack away. And so what I'm going to attempt to bring up for you here, that I may need to just, go over here. While this data is kind of settling down, what I'm showing here in the green nodes are labeled tools that were used. The orange are the users with their usernames. And then their sizes reflect either if it's a tool, how many times that tool's been used, or if it's a user, how many times that user has used the tool. And so what this gave me the ability to do is, once shared with the project team, we could see here, okay, we'll click on a user who's used tools quite a bit. The thickness of the line represents how many tools relatively they've used. And so if we want to look at another one of these tools, something that he's used quite a number of times, we can click on that tool and see what other users are using that tool. And so if we take a look at other users, we can see, OK, this user is also using that tool quite a bit. And now the initial user can find out, are there any tools here that somebody that's using similar tools to me I'm not familiar with? And so this is a way that it helped me connect users to each other and users to tools. And with that, I'll thank you for your time.